Need to expose application status, configuration, or dynamic data to your AI models or client apps without building a full API. You'll see how FastMCP at resource decorator lets you define typed, self-documenting data endpoints in just a few lines. We'll customize metadata like MIME types, tags, and versioning while keeping the implementation clean and maintainable. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals data server. Hash example specifying metadata. At MCP, resource. URI equals data //app status. Hash explicit URI required. Name equals application status. Hash custom name. Description equals provides the current status of the application. Hash custom description. MIME type equals application/JSON. Hash explicit MIME type. Tags equals monitoring. Status. Hash categorization tags. Meta version 2.1 team infrastructure. Hash custom metadata. Def get application status. Dict. Internal function description. Ignored if description is provided above. Return status. OK, uptime, 12,345 version, MCP settings, version hash example usage. This demonstrates the resource registration pattern for exposing structured data endpoints in FastMCP. The approach uses Python decorators to transform ordinary functions into addressable data resources, creating a clean separation between data provision and business logic. What makes this distinctive is its ability to handle both static metadata and dynamic content generation through a single, declarative interface. The pattern operates by treating decorated functions as lazy-loaded data factories. When a client requests a specific URI, FastMCP dynamically invokes the associated function, serializes the result according to declared MIME types, and returns it as a resource. This design enables on-demand data generation while maintaining a consistent interface for clients, whether they're LLMs, web services, or other systems. The metadata system further enhances discoverability by allowing resources to self-document their purpose, structure, and usage constraints. This approach solves the common problem of exposing backend data without building custom APIs. It's particularly valuable in AI integration scenarios where models need structured access to dynamic information. The trade-off is minimal runtime overhead for the decorator system, which is justified by the elimination of manual API development and the ability to modify data endpoints without client-side changes. The pattern shines when you need to expose many data points with consistent access patterns, but varying implementation details. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI callable resources. It transforms Python functions into network-accessible endpoints with automatic schema generation and metadata handling. MCP equals FastMCP. Name equals data server. This initializes the FastMCP server instance named data server. This central object handles all tool registration, request routing, and connection management for your AI callable functions. The name parameter identifies this server in logs and monitoring systems. Hash example specifying metadata. At MCP, resource. This is FastMCP's resource decorator pattern, exposing Python functions as AI-accessible endpoints. The decorator transforms this function into a managed resource with full metadata support, enabling discovery and proper handling by AI systems. All configuration, URI, MIME type, tags becomes part of the resource's contract. URI equals data //app status. Hash explicit URI required. The URI parameter defines the unique address where this resource is exposed. Required for all FastMCP resources, it follows the data / scheme to distinguish it from HTTP endpoints, enabling direct AI and tool integration. This explicit addressing prevents naming collisions and ensures reliable discovery across distributed systems.
Name equals application status, hash custom name.
The name parameter assigns a human-readable identifier to this resource, overriding the default function name. This enables clear documentation and discovery in FastMCP's resource registry, while maintaining the original function name in your codebase.
Description equals provides the current status of the application, hash custom description.
This provides human-readable documentation for the resource. The description appears in API listings and tool documentation, helping developers understand the resource's purpose before calling it.
MIME type equals application/JSON, hash explicit MIME type.
This explicitly declares the response format as JSON, ensuring clients and tools know how to parse the data. FastMCP uses this to validate responses and generate proper documentation, eliminating guesswork about the data structure.
Tags equals monitoring, status, hash categorization tags.
The tags parameter categorizes this resource for discovery and filtering. AI models and monitoring systems use these tags to quickly identify relevant tools, like finding all monitoring endpoints. This follows the standard metadata tagging pattern for API resources.
Meta version 2.1 team infrastructure hash custom metadata.
The meta parameter attaches arbitrary key-value metadata to the resource, enabling custom categorization and version tracking. This supplements the structured tags system with freeform data, useful for internal tooling like deployment tracking or team ownership. FastMCP preserves but doesn't interpret these values, treating them as opaque labels for external systems. This closing parenthesis terminates the @MCP resource decorator configuration, finalizing all metadata before the function definition. It's the standard Python decorator syntax that applies all specified parameters, URI, name, description, and metadata, to the function that follows. Without this, the decorator would remain incomplete, causing a syntax error.
Def get application status, dict.
This defines the actual resource function that FastMCP will expose. The dict return type hint becomes part of the tool's schema, ensuring AI clients receive properly structured JSON responses.
Internal function description, ignored if description is provided above.
This docstring is ignored when the decorator provides its own description. FastMCP prioritizes the decorator's metadata over the function's docstring, ensuring consistent documentation from the resource definition rather than implementation details.
Return status. OK, uptime, 12,345 version, MCP settings, version hash example usage.
This returns a JSON response with the application's current status, including uptime and version. The MCP settings version dynamically injects the server's configured version, ensuring consistency across all endpoints. This pattern guarantees the status endpoint always reflects the actual running version. Resource metadata pattern. The @MCP resource decorator transforms Python functions into addressable data endpoints, where explicit metadata overrides implicit defaults for precise control. Omitting the URI parameter raises a clear error. while other metadata fields gracefully fall back to function attributes when unspecified. This declarative approach ensures resources are self-documenting from definition through consumption.
The resource that names itself becomes nameless to those who need it most.